Welcome to the next video lesson. In this lesson, we will be discussing about the 7 quality control tools, which is also known as the 7 QZ tools. These are great management tools for the project managers to really leverage for effective project management. These are the 7 QC tools. We have the check sheets, then the flow charts, Pareto chart, cause and effect diagrams, histograms, scatter diagrams, and the control chart. Check sheet is widely used to uh, to take the number of occurrence of different categories. So check sheet is a very simple stuff where we can measure the number of occurrence of each uh, defect type. In this scenario, they have given defect types. So in the first category, okay, we have this many defects coming up. So we use a check sheet to count the different categories, the occurrence of different categories. Then we have a flow chart. We use flow charts to analyze the process flow. If something goes wrong in the process, we use a process flow chart. It can be as a retrospective, something has gone wrong and we want to analyze where it has gone wrong. Maybe we can use flow charts. Or if we want to optimize a process further, we can use flow charts there as well. So this is basically to analyze the process flow. We use flow charts. Then we have Pareto charts, cause and effect diagrams, histograms, scatter diagrams, and the control chart, which we will explain in detail as we progress. Now here is the Pareto chart. Pareto charts are based on the 80-20 principle. When I say 80-20 principle, for those people where 80-20 is new to them, that is a heuristic. 80% of the population is in 20% of the countries. 80% of the wealth is with the 20% of the people. 80% of the work is done by the 20% of the people. So this is a heuristic or a rule of thumb. The same thing when we translate to project scenarios or quality scenarios, here we have poor planning. Because of poor planning, we are getting around 40 defects. Or poor planning, around 40 occurrences, and change of scope, 25 occurrences, resource unavailability, 15 occurrences, approval delays, 10 occurrences, and contractor performance, 6 occurrences, material delivery, 3, and others, only 1. So instead of trying to solve all the problems, Pareto analysis helps us to focus and solve the issues. So now here, if we can resolve this 3 out of maybe these many, if you can focus on the first 3, we should be able to eliminate 80% of the problems. So by focusing on 20% of the root causes, we will be able to eliminate 80% of the defects. This is very useful. In one scenario, I still remember where the acceptance testing of the product was going on. And when we test the product more and more, we were getting more and more defects. So where do we start? And at some point in time, we have around 100 defects to close. And when we try to close it, we are injecting more defects. That is a time when Pareto analysis really helped. We took a sample out of this 100 and analyzed the root causes, and we analyzed the occurrence of the root causes. We did a Pareto analysis by plotting the causes on the x-axis and the number of occurrences on the y-axis. Suddenly, we were able to identify the biggest contributors to these defects. The 20% of the causes that were contributing to 80% of the defects, and we attacked those causes, and suddenly the defect count came down. So that's why I'm saying these are all great project management tools. And because they are known as QC tools, we tend to believe that it is only for the quality control department. That is not the case in project management. So we discussed about check sheets. We discussed about flow charts, and we discussed about the Pareto chart as well. Then we have the cause and effect diagrams. Cause and effect diagrams are also known as Ishikawa diagrams or fishbone diagrams. It is all same. Cause and effect diagram, Ishikawa diagram, and the fishbone diagram, it's all same. Now, in this scenario, here we are getting schedule delays, and we want to identify the probable root causes leading to the schedule delays. Now, do we have any equipment related issues? We brainstorm with the team and come out with the probable root causes. Is there any problem with the equipment we are using? We get a set of root causes under that category. Is there any problem with the material we are using? We get some probable root causes here. Is there any problem with the manpower? We get some root causes here. External root causes, management related root causes, environment related root causes, methods related root causes. So this gives us to do a structured brainstorming and to collect the probable root causes. And once we know the probable root causes, then it is about doing a Pareto using those root causes. So cause and effect diagrams are always used to analyze past outcomes. But personally, I've used it for planning as well. So I want to achieve, let us say, plus or minus 5% variance in schedule. That is the target I want to achieve. So in order to achieve that much, what all things I must control? So we can use it in a proactive manner as well. But generally, it is used in a reactive manner to analyze the past outcomes, why it happened, kind of thing. Great tools for project management. Then we have the histogram. This most probably everybody will be knowing it. So this is based on distribution of task durations. Now 0 to 5 days duration, we have 4 tasks. 5 to 10 days duration, we have 12 tasks. 10 to 15, it is 28 tasks. 15 to 20, this many tasks. So in this example, on the x-axis is the task duration, and on the y-axis is the frequency or the number of tasks. So this can, and depending on the scenario, what goes on the x-axis and the y-axis will keep changing. So this is a histogram. Then we have a scatter diagram. Okay, we know we are getting defects, and we want to localize those defects from where it is originating from. Or we identified the 20% of the defects of the causes contributing to 80% of the defects. And now we want to analyze from where these causes are originating. Now, in this particular example of the scatter diagram, uh, this is about defect severity across modules. So here on the x-axis, we have put the modules: authorization module, user interface module, payment module, order management, inventory, reporting, notification, etc. And on the y-axis is the severity of defects: low severity, medium, high, and critical. And now we keep plotting. Now against authentication, we have two critical defects, and we have high severity two defects. So likewise, we plot. So this will help us to identify the affinity of these defects against the modules. Again, from project scenario to scenario, what goes on the y-axis and what goes on the x-axis can change. In this particular example, the x-axis has the number is the number of modules, and on the y-axis we have the severity of defects. Similarly, on the x-axis we can put the team members also, so that we can identify who is the biggest contributor to defects. After that, it becomes easier to solve it. Then we have a control chart. So there is a general saying like, whatever you want to improve must be measured. Without measurement, improvement is not possible. So here in a control chart, in the middle we have the mean, and in the red dotted lines are the customer specification limits. In this scenario, the customer has given us an order and says there should not be there should not be deviation, 25 more than 25% deviation in the schedule. So they don't want to complete it too much ahead of schedule. At the same time, there should not be too much delay beyond 25 days. Then our organization has certain capabilities defined for schedule performance. Based on the historical data, the organization has always performed within plus or minus 20. That is the green dotted line. That is the organization's capability baseline. So we call it as the upper control limit and the lower control limit. So that is the organization's capability baseline. Now, one occurrence is happening here that is no problem because it is falling within the upper control limit and the lower control limit. Data point 12 also no issues because it is falling within the upper control limit and the lower control limit. Now data point 21, the customer will not complain, but the quality department has every reason to be concerned because it is outside the upper control limit of the organization. So there is a process deviation. So you take some corrective action, push it here, no problems. Here, if you see the data point 28 is lying outside the customer specification limit as well. Now, customer has every reason to raise a complaint or put penalties or whatever, and so you do a root cause analysis, take corrective action, push it down. Here again, it is going outside the lower control limit. Customer will not complain, but the quality department can complain. So as long as these data points are within the LCL and the UCL, or the upper control limit and the lower control limit, we say that the process is under control. So whatever we want to improve must be measured first. So that is a control chart. And another key thing to be remembered here is there is something called the rule of seven. So in a control chart, if you get 7 data points next to each other, then we call it as a rule of 7. So wherever you see in a control chart, wherever you see 7 data points happening next to each other, or a cluster of 7 data points happening next to each other, we call it as a rule of 7. And whenever we see a rule of 7, we are supposed to take corrective actions. So we discussed about the check sheet. We discussed about the flow chart, Pareto chart, cause and effect diagrams, histograms, scatter diagrams, and the control chart. So these constitute the 7 QC tools or the quality control tools. And these are great tools for project managers to really manage projects professionally. In one scenario, one team I still remember, I trained all my team members to do a cause and effect diagram. And we said, before any issue resolution meeting, please come with the cause and effect diagram or the Ishikawa diagram or the Fishbone diagram. It's all same. So the advantage I got was many occasions the meetings got cancelled because by the time the team members did the Ishikawa diagram, they understood what is the problem. So meeting was not required. So that is the ROI I got by training my entire team on the 7 QC tools and mandating them to use these tools in real project scenarios. So thank you very much. I believe that you got good value from this video lesson. And for more information about the topics covered, the link to the PM Distill guide of the page on the 7QC tools is given in the description of this video. So you can click on it and you go to the 7QZ tools page on the PM Distill guide. And if you have not subscribed to our channel yet, please do subscribe to PMRI Campus so that you will not miss out on any latest updates.